Ya-
Ya me la
Ah,
aviento. Es que tengo que hacer
Hola,
un...
¿pueden confirmar que se escucha en Facebook y YouTube? Y mientras tanto, Gover, ya estamos en directo, ¿eh?
Sorry, lo noté.
Don't worry. Am, bueno, nadie confirma, pero podemos asumir que se escucha. Ah, ok, ya confirmaron, sí se escucha. Am, bueno, hoy vamos a continuar con el tema de la última vez, el de, bueno, acerca de las entrevistas. Hoy vamos a hablar de los topics, lo vamos a dar en inglés. Solo quería aprovechar este tiempo, bueno, si vieron nuestras redes sociales, publicamos ahorita una nueva actividad que vamos a estar haciendo, son las charlas en inglés. Cambiamos un poco la modalidad de lo que estábamos haciendo. Ahorita van a ser charlas uno a uno. Esperemos que así les dé más confianza para practicar su inglés. Si en un futuro quieren, podemos también volver a retomar las sesiones, las pláticas grupales. Pueden encontrar más información de eso en nuestro último post. Y también estamos iniciando otra modalidad. Los que están en el Discord tienen un poco más de información. Pero para las mock interviews, si ustedes así lo quieren, podemos hacer, bueno, podemos, los que saben inglés pueden revisar sus mock interviews para hacer comentarios eh, sobre detalles del inglés, bueno, de la parte, pues, de cómo lo hablan, de frases equivocadas, errores que hayan tenido, etcétera. Solo esto me parece importante mencionarlo. Los comentarios no van a ser. Bueno, todas las mock interviews son anónimas, o sea, lo único por lo que podrían reconocerlos es por su voz. No vamos a poner como quién es su usuario en Discord ni nada de eso. Estas revisiones vamos a publicar los videos en YouTube, ya sea privado o público, como ustedes nos digan, pero vamos a dar prioridad a las revisiones públicas. ¿Por qué? Porque si son públicas, toda la gente las puede revisar, o sea, no tienes que hacer tú la mock interview para ver como pequeños errores que se pueden cometer. Bueno, pusimos un ejemplo de una que hicimos con unos cuantos comentarios y revisan los timestamps del video. Le dan clic al minuto y ahí inicia una parte de la conversación que es el contexto y aparece un slide azul con comentarios del inglés. Eso lo hicimos un poco para que puedan tener un poco más de feedback en sus mock interviews, si así lo desean. Bueno, ya es todo. Sergio, Andrés, are you ready?
Yeah.
Yes.
Okay, so let's begin with today's topic. Let me change the. Oh, that's a spoiler. Sorry for that.
It happens all the time.
Okay, I think now it's fine.
Yeah, well, thank you very much, Manuel. Well, today we are going to talk about the topics of the interview, for the interviews. When we talk about topics for the interviews, we mainly focus in two ways, in data structures and analysis of algorithms. So yeah, we can continue. So yeah, when we are analyzing an algorithm, we are going to focus mainly in two types of complexity. When we talk about complexities, we are going to use maths to represent this complexity. So basically, there are the two types of complexity we are going to analyze are the time complexity and the space complexity. And the reason we're using math is because math is a very efficient way to represent how slow or how much information we are storing. We are going to make a really easy example. But before I talk about that example, I want you to know if everybody of anyone in the comments or here in Discord do they know that what is a big O? So wait a little, like just a few seconds to see if anyone can put in the comments, I don't know, or I do know, because it's like a kind of important. Well, nobody's saying anything. But anyway, let's say what is big O. When we are talking about big O, we are talking about the way in computer science we represent this type of complexity of time and space. So we use this literally a letter big O and a parenthesis. Inside of this parenthesis, we are going to put a mathematical function to represent how this complexity grows in respect of the input. The most basically or easy way to represent this is with constant. When we talk about constant, we are talking about a simple number. By default, we use the one, and that means that no matter how big the input is, the time that it will take to resolve a problem is not going to change. That's with time. And when we are talking about space, we are saying that we do not need any extra space other than the input. So most of the time we are dealing with these problems. They are two trade-offs. We can make a program run faster if we use more memory, or we can make a problem with few lines of code, but it will maybe it's going to take a lot of time. So you are going to make these decisions when you are going making the interview, and it's really helpful if you know about how does these algorithms grow. I will recommend everyone to talk about to study a little more about big O and how this works. The example I want to do is like I wish you to all to imagine a simple for loop. So we have this for loop that is going to iterate uh, n times. Like when n, it's going to change by the input of the user. Like if we start with this for loop, uh, it's going to grow in time as long as the user put a bigger number. So this is going to be we say that it's linear, and we can imagine like in the school when we used to see a line growing from like in the beginning of the time is in a low position, and at the end is going bigger, but in a way that's straight. Then I want you to all to imagine that in this for loop we are putting another for loop inside that is running exactly the same, the number of times that the user put. So when we do that, we have to imagine that this for loop is making an iteration for each time the previous for loop is running. And when we do that, we are going to do something that we call like annotating the for loops. And in terms of big O, it's like we are multiplying n by n, that giving us n to the square. So this is basically that the way each and every line of our code that is going to be written is going to affect the time, and the but not all the time is going to affect the space of the algorithm. That's why most of the time in the interview they will be just good if they are just if you just talk about the time complexity, because it's the most important for most of the companies. But it will be good practice if you say the both of them. When we are talking about space complexity, we are talking about what, for example, if you need an extra array to solve the problem, or two variables to solve the problem, when you have to talk about those variables and how they will impact the overall performance of your algorithm. So that's everything we are going to say about complexity. And the reason we are using maths is because, yeah, linear, if you remember, is just a letter in mathematics. If you are talking about a logarithmic way of solving this, uh, you can use the function logarithmic, and you can use different types of arithmetic equations to represent this change in time and space. And that's the way, what's gonna be the better way to express yourself to anyone who is in the computer science, regardless of which language they are speaking, because mathematics are universal. That's why we are using maths. But don't worry, don't freak out. They are not going to be any hard equations. You are not going to solve anything. You just need to know which is the best equation for their purposes. There are a lot of cheat sheets on the internet, so you can put search really fast in Google like big O graph, and they are going to show you how these equations are, which are the most used in the program interview. Um, I could tell you about the linear, the square function, the logarithmic function, and the quadratic function. That's going to be the most important ones. So just to remember to use this and to practice a lot. Every piece of code that you wrote, try to imagine how much time it's going to take to solve in terms of big O. So going to the next part, we are going to talk about these structures. The most basic structure you could use most of the time is going to be time of the input is the array. And an array is just a way to sort or have your information in a accessible way, in an order and accessible way. The most basic is a one-dimensional array. That one-dimensional array is just well, the one-dimensional array is the most basic one. Is just a line of order elements. You can access them by the indexes, and they are going to have the information you are going to use. So these kind of structures, you can iterate from them from the beginning. You can iterate from them in a lot of ways, but the most basically ways are from the start to the end and the end from the start. This is going to do a lot of information computing. And if we are talking about complexity, there is going to be to iterate to all the array. If we use the letter n to represent all the elements inside the array, it's going to be linear. We can just go for each element one time. So this is going to be n in time to represent. Also, we have the two-dimensional array. So the two-dimensional array is also called matrix. And this is because we have a grid or a window of a lot of elements. So it's like if you put a one-dimensional array in top of another and another and another, and we got a two-dimensional array. And it's called two-dimensional array because we have two ways of iterating instead of just from left to right. In this case, we can go up and down and left to right. And well, most of the time, if we want to iterate for a two-dimensional array, we are going to need two for loops, one for the width and one from the height. And if we put a letter n for the width and a letter m from the height, we can say that the time we are going to take to look for each element inside this 2D array is going to be the multiplication of this n by m. But what will happen, for example, if the height or the number of columns and the number of rows of this array is equal? In that case, we can say that n equals m. So when we multiply two letters that are the same letter, this is going to be a square. So we can see that the time complexity is going bigger than in the 2D array. When the 1D array is linear like n, the 2D array that has the same columns and the same rows is going to be n quadratic. And it's going to take more time. And it also is going to take in average cases more space. Lastly, but not the lastly really, we have the 3D array. I say not really the lastly because after this we can have 4-dimensional, 5-dimensional, and n-dimensional arrays, like some crazy stuff that we can't even imagine how they will look in real life. We cannot give it a representation, but they do exist in computer science. But this kind of arrays, we are not going to see any of those strange arrays in coding interview. Even more, it's really rare to see 3D arrays in a coding interview, but you can get to see one. And it's a 3-dimensional array because we are putting a new dimension to this kind of arrays. We are going to give it a deep of each of the elements inside the matrix. So as you can see, this is going to make another for loop to iterate to each element. That's because we have to access to each row, and after we access to each row, we have to access each cell, and after we access each cell, we have to access the deep of that cell that's containing another list. So these kind of 3D arrays, we are going to need, as we say, another for loop. As you can imagine, if we say that the width or the number of rows, the number of columns, and the number of the deep of this array is all the same, they are all the same number. They have three, as for example, in this case, we have 3 rows, we have 3 columns, and the deep is of 2. Well, we would say like we have n quadratic multiplied by m, where m is the deep. If we get another one, all will be n, so it will be n cubic. So as you can see, the more complex the structure becomes, the more time it will take you to iterate to each element. And this is basically the way you are going to go into the interview, because the information, the problem is going to be most of the cases in one of these 3 type of structures, and knowing how to iterate from it and look or search for information inside these elements is going to be really important. As I mentioned, there's the most easy way to iterate through each element is for a for, but there are other ways you can manage edge cases. For example, when we have this this matrix, we can if we are in the middle, we can go up, we can go, if there's an element down, we can go left, right, but also we can move in diagonals. But that's not true for the corners of the matrix. So how would you manage to that these cases? For example, if you want to move in the corner more to the in a diagonal, well, you will need to have an if statement. If I already add in the corner, don't try to move either up or left or in diagonal up or left, because it's going to make an error. So there are different ways you can approach these solutions. They are the most basic one is the one I already told you, using the if, but there are other ways to solve this problem. And the only way you're going to discover this is to check other ones' code. Try to solve as many problems as you want, but don't get in that. Don't stop there. See who has the most efficient solution for that particular problem you already solved, and see the code. Try to analyze what they did, and you are going to learn a lot of good stuff because of that. I really recommend you to do that. A lot of judges, for example, lead code and code forces, let you see the code of other people, and that's going to help you to learn a lot. I don't recommend you to go to code forces because sometimes the people there are really, 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 really good, and the code is really, really, really hard to understand, but also really, really efficient. So just start small and keep growing from there. The next data structure we are going to talk about is going to be strings. This is also a most important topic. Before we get inside this string, like a whole topic, I would like to talk about a little why strings are important for this topic. Depending on the of the programming language you choose to perform your interview, there are going to be different kinds of throwbacks or good practices that you may use. For example, when we talk about strings, much languages like Python and Java, they manage strings like unmutable objects. What this means is that you can delete or change a character inside this string as easy as you will do with an array, because this is going to take more time of computing. If you want, for example, to concatenate a string with another string, you will need to create a new string that is made from both strings. So in terms of computing, that it's a lot of power of computing, because the most efficient way will only be like to take the first string and make bigger the array and append the other string, right? Because we don't have to copy element by element of both strings. But as we say in Python and Java, that's an immutable object, and that's going to be, for example, sometimes when you want to access just a substring of the string. Like, for example, if you were present or you saw the video of the interview we did last time, I was using a Python function to get in the substring of a string. And because strings are unmutable in Python, well, that makes me a linear algorithm inside my algorithm. So that's going to be a drawback if, for example, it was inside a loop. So you have to be careful of how do you manage, or how do you use the strings depending on the language. So you try to get informed about the language you're using and how the strings are represented inside that language. If you want to know which language is easiest to manage strings, that will be, in my opinion, C++, because it's a mutable object, and the strings functions, they work really fast. But also you have the drawback that you will need to deal with C++ syntax. And well, that's another whole story, but C++ is not well known to have just one standard of string, so be careful about that. And well, getting inside the string, what you will be requested to do, or what you can do to a string, is, as we say, like searching. Well, you can search each character inside the string, and maybe you want to know, like, if there is an O inside the string. That will be a basic. But the most important thing, or another important thing, is like you can, or you will be requested to do to search for a substring. What is a substring? A substring is just a string that is formed with elements inside the string, but these elements have to be all continuous. Like, for example, we have this string technology, and if I want a substring, it could be one that begins in the first index and ends in the fifth index, and all the elements have to be continuous. So it will be eknolo. Maybe eknolo is they will give you a function that they say, like, I will give you a lot of strings, and I want you to return me the number of strings that exist inside this string. So you will be requested to look for all the substrings. As we told you, there are a lot of ways we can do that. We are going to talk about that in another workshop, but suffice now that looking for a substring will be really important. All other things that you might encounter with the strings is the prefix. Prefix are just a way to say that a substring, but that starts in technology. There are a lot of prefixes. The first prefix will be the T. The second prefix will be the TE. The third will be the TEC, and so on and so far, like going from the beginning all to the end. As the same apply for the suffixes, that will be the but starting from the end and going to the beginning. So the first suffix will be Y, the second suffix will be GY, the third will be OGY, and so on and so far. So well, that's going to be how strings may use inside the interview code. That's really important to know. As I told you, like to know how the strings objects or the string types behave in your preferred language program of language, because that's going to affect the way the interview is going to tackle your box, or how do you are going to manage this, or if there is a better way to solve the problem. um, I think that would be the most important things of strings. So the next data structure we are going to talk about is going to be queues and stacks. Uh, Previously, we already talked about one-dimensional arrays, and the one-dimensional arrays are really basic but really powerful to understand, because a lot of algorithms and structures are based in that data structure. One example will be the queues and the stacks. We can use one-dimensional arrays to uh, to create these kind of structures. We are going to begin with the queues. And when we are talking about queues, we are talking like representation of the real life of a queue. If you have been in a supermarket, you have been in a queue, and the queue is when you are waiting for you to pay for all your groceries in the line. So the queue works in a way we call FIFO, meaning first in, first out. The first that goes in the line is the first that's going to be attended by the cashier, and that's why we are making queues. And queues are really important because they are the base uh, of the algorithms when you want to trade each element in the order they appear. So when we talk about queues, we have this one-dimensional array, but the way we are accessing the elements differs in that we only can access the element that's in the front of the queue before we access the last one. So when we want to append an element to a queue, uh, we basically are saying that we want to enqueue. Instead of saying another language, it's really important to use this kind of words, because that will help you to your interviewer to understand that, oh, well, this guy is talking about a queue. He is going to get in synchrony when what you are trying to do. So enqueue will make an element go in the back of this array, and the queue is going to take out the first element that it's in the queue. So inside this queue we have two main pointers. One pointer is always going to be in the front of the array, and the back is also always going to be pointing to the back of the array. Queues are really important when you are trying to do some other bigger algorithms that we are going to talk later. But for example, there will be a type of algorithm called BFS that relies heavily in queues if you want to tackle it in a certain way. Um, Queues are also, as they are one dimensional arrays, they are treated equally in terms of time complexity. They will be in linear time. That's the time you're going to take to see or visit each element inside a queue. And well, as I told you, you are going to be using mostly the enqueue or dequeue function to get an element from the queue or to put an element inside the queue. The other algorithm that's like the as the same mostly is the stacks. The difference of a stack is in this way is a structure we call um, philo. Sorry if I don't know how to pronounce this in English, but the meaning of this is the first in is going to be the last out. That means like you have seen stacks in your life. I assume that you have been working with dishes when you are washing them. When you put a dish in top of another and another and another, accessing the first dish you put would be difficult, because if you take it out, all the stack is going to crumble and fall in the floor. So that's why stacks are only accessing with the element that's in the top, and the element that is in the top is going to be the last element you have put in the stack. So that's a real representation of what stack is. And in computer science, we have this structure to help us to treat elements in the order they are arriving, but always taking in the priority the last element that has inside. So queues have in a different way, they will going to have two different methods to access the elements. Instead of calling them the queue or in queue, we call them push and pop. Push is going to put an element inside this queue, and pop is going to take the element that is in the top of the stack. So in this case, we don't really need a pointer telling us which is the back, because it's not going to be important, because we are just only taking into account the element is in the top. And as you can see, well, if we have an empty stack at the beginning, we have nothing. That is a really interesting part by itself, because you could argue what happened if I use the function pop if the stack is empty, and that's an edge case. And that's going to be it's really important that you start to thinking about these kind of stops, these kind of things before your interview, because that's it's what is going to be expected. It's going to help you a lot to nail the interview code. Well, at the beginning, the stack is empty, and if we put an element, the element is going to be at the bottom of the stack. After that, we are going to put the number 2 in this stack, and the number 2 is going to be just in top of the 1, because 1 is the only element we have in the stack. Well, after that, if we want to pop an element, we can only get one element from that stack. That is will be the 2, because the 2 is going to be at the top of the stack. As you can see, this is going to be also a one-dimensional array, but you can imagine this array, instead of drawing it from left to right, we can draw this dimensional array from bottom to top. And because it's a one-dimensional array, in time it will be also linear. We are going to iterate from that element by element to the top, up to the bottom. That will be stacks will be also important, because as I told you, there are other algorithms that rely heavily in this structure. For example, there is the algorithm from Deep DPS, I remember it is the name, and it relies heavily in stacks. So we are going to talk about that algorithm in the future, so don't worry. Just suffice that it's important, and it's going to be used in other topics as well. Well, this next structure we are going to talk about is linked list. And the linked list is going to be in 3 types of flavors. The single linked list, the double linked list, and the circular list. And most of the times there are other ways, but these are the 3 main ones that you will be using in your coding interview. And the single linked list is really simple. We have a simple list, like from all your time, starting from a node. We are calling this node because, like in contrast with the array, we are not using indexes to access the next element. In this kind of structure, we are using arrows that represent, in some languages, pointers, or that represent that the next information is existing in a different memory location. So, well, the simple linked list you can only move from one position to the next one, and to the next one, and to the next one. Um, it's really important to see that we always, always, always we are going to have a pointer that it's pointed to the beginning of the list, and we have to be really, really careful about this pointer, because if we lose reference from this pointer, reference meaning that this pointer is always have to be pointing to this starting node and not other way, because if it points to another node, we are going to lose forever the beginning of this list. So we have to be careful with that. And after that, that's the reason we are using sometimes more than one pointer. So we are not never going to move the head pointer, but maybe use another iterator pointer to move from one element to another element to another element. And if you've been working with Python, that's basically the way it works. It's not the way it works, but most of the idea of how do you iterate in that way. You are just going from element to element to element, like using an iterator. So, well, when we have this, when we are talking about linked list, each of these elements are called nodes. Why we call them nodes? Because a node is not just information. A node is a small structure that will be representing all we need to save or to know about the structural linked list. In this case, we are only needed two things: the value of the current node and a pointer to the next element that is in front of this node. So that's why we are using nodes, and each node has a pointer to the next one element up to the last one. When we get in the last element, well, we have this pointer, and this pointer, because it's a simple linked list, has to be pointed to nothing. And in most languages, you can say that it's null pointer in C++, or null in Python, or null in Java. But it's important to add it's pointing to nowhere, because that's how we are going to say to the algorithm that, okay, you have finished. There is nothing else to look for. You can stop iterating in this linked list. Linked lists are used in a lot of problems you can solve. Mostly, like, for example, to get a contact or information about that. And the main advantages of a linked list from an array is like insertions and deletions. They are way faster in a linked list like they will be in array, because in a linked list we are just going to move the pointers, and that will be really fast in compare of making more space for, or creating more space from an array. uh, Taking a pointer and get the reference to another node, it's way easier. And we can say that if the code is really good, it will be in constant time. Like, it's not going to take any difference of time for the size of the times you have to put a new element. So, well, we have talked about the node. That's the structure that it's the combination of the value and the pointer. The value is going to be the in this case a number, uh, and the reference is going to be the pointer that's going to help you to go to the next element. Well, then we have the double linked list. In this case, as you can imagine by the name, double linked list meaning that we have two links, two nodes, two references that will help you go from left to right. As you can see in the single linked list, the drawback is that we only can go in one direction. And that's really a pain, because for what will happen if you are in the number 2 and you want to get back to the 0? Well, if that's the case, you will need to start all over again the search, right? Well, in double linked list, we don't have that problem. We have the only drawback is we will be needing more space to save the reference for the two pointers. That's an example of what we were talking about, that the trade-offs or space and time complexity. You can use more information to get your algorithm faster. So as same, we have a node. In this case, the node, we have an extra space for the other pointer, and that's the way we are going to iterate. So we can go from the 10 to the 11, and the 11 go back to the 10 using the other pointer that we are using. And as the same as the single linked list, we are going to be in the need of another null pointer, right? Because the start of the list cannot have a pointer to the other way. So we have to say that, well, the pointer, the back element is null. So you don't need to look anyway past me, and the same applies for the last node. The next pointer has to be pointing to null, because you don't have to look anyway further from the 13. Um, so that's a implementation of a more efficient in time list, and that's going to help you to go really really easy. So the only drawback is like you will be needing more space for the next reference, as I said, but also that the functions of inserting a new node and deleting the new node, they could become a little more complicated, because you have to move to pointers, and moving pointers sometimes is going to be messy if you don't are careful enough. So you can have a really bad outcomes. One outcome would be like you destroy for completely destroy the structure of the double link, and well, you lose a chunk of information. So just be careful when you're implementing that. The Lastly, we have the circular linked list, and the circular linked list is a another way of seeing the linked list, but instead of saying that the last element is the end, we can go back to the first element. So circular linked list, we're just going in circles like it looks. Um, that is really helpful. For example, if you want to iterate like all different times of or different times in the same linked list, the only drawback is like you have to be careful to never lose a size where the node the circular list start, because well, a circle doesn't have any beginning, right? But you have to start somewhere, because if not, you are going to get in infinite loops. um, but as you can see, the structure of the node is basically the same. We're just connecting the last node with the first node. Mm, I encourage every one of you to implement these three types of list. They are really simple at once you get used to the structure of these kind of data structures. And well, basically there's going to be all about these linked lists, but they might be another type of list, more complex, but these three are the most important ones, and they are going to be the one that you will be using in your coding interviews. Well, the next
I
data.
want to add something else,
Yeah.
referring to linked list as well as the message that was sent is one of the most common topics in the first semester of the careers. Also, is a topic that is not really common. Let's say in competitive programming, all the other topics are common, but I think the linked list is not really common in competitive programming, and is one of the biggest difference with interviews. In interviews, is a topic that I would say is common, and that's why, as Andres said, it's important for you to study. And also referring to the well to the other thing that Andres mentioned, yes, there exists another uh, uh, variations of the linked list. Also related to the queues and the stacks, there is another data structure called uh, the queue, double-ended queue. If I'm not wrong, Sergio, can you confirm?
Yes, that's the name. DQ.
Okay, that's another data structure that in some cases appears. It's not really common, but also you can take a look of it. Especially you're applying to Google or something like that that use not the usual topics, let's say. And well, another difference with the linked list and the queue and the queue, the queue and the stack, is that most of the programming languages has implemented the queue and the stack in the standard library, like C++. So sometimes you don't need to uh, code again the data structure. But for example, if you use a programming language like C, probably you need to program that data structure because it doesn't exist in the standard library. That's why it's important to choose a nice programming language to do your mock interviews. Your interviews. Well, also your mock interviews. And we have another question from Cuestionalo Todo. Is there a recommended order in which I should learn topics? Well, as the message said, is suggested starting with arrays, linked list, and strings. Also, you can follow the order that is in the Cracking the Coding interview. If you don't know, the book is like the Bible for the interviews. Cracking the Coding interview. I don't remember the author, but is a woman that was working in Google, and well, she started working to help the people to join in these companies.
Yeah, her name is Gail Lickman McDowell.
Well, you can let me Cracking the Coding interview.
Well, that's also true, but also you can go to HackerRank. It's the page of the same author, and there is going to be a section for interview preparing for your interview,
Interview
and that's
Preparation Kit is the name of the course.
yes, and that's the order that this author suggests that you should learn everything, and it's really cool because it also has a lot of problems relating to those topics, so you can practice with that.
Yeah, well, I would search the course and I will send it. Well, if you don't have any other question, we can continue.
Yeah, going to trees, heaps, and maps. Well, a tree is a really cool data structure that we are going to use to save information, but also to access them in a certain way. Trees, they are going to be two important things we have to know that trees has a parent and a node. The parent that is the parent of all the nodes is going to be called the root. That's why we are going used to they are called trees because we have a root, and we say that each of the childs they are leaves, like in a tree way. Also because they a lot of times we see like a familiar tree representation, and they look it's more or less the same. We're talking about trees. We are going to be focusing mostly in how to look or traverse these trees. There are different ways in we can go transversal. The names of the transversal is going to be in order, pre-order, and post-order, meaning that which node is going to be processed first and lastly. Um, if you like, you can ask for that kind of transversal, and we can talk a little more about them later. But well, in this case, we are just presenting this structure. And as you can see, the main importance of this is going to be just the information and how we access them. Um, so we can start from the root, and we can go for the left children, or maybe to the left children, and going all the way back in the search of information. So most of the time we are going to be searching for some kind of information inside these trees. There are different kinds of trees for different kinds of problems. Most of the commons are binary trees. Like this example is a binary tree because the parent only has two childs, but they are maybe have more. But binary trees are the most used in the topics of the interview, and there are two types of binary trees. Well, there are a lot of sorry, but right now I want to talk about the perfect binary tree and not perfect binary tree. Perfect is going to be when all the nodes has all the childrens, an imperfect will be like some may not have any children at all, some might have children, and well, one of the uses of binary trees is going to implement the binary tree search, that you can, if you order the elements inside this tree in a certain way, you are going to be making a really fast search in time. We call this time logarithmic because we are dividing by two the scope of searching each iteration. So talking about that, we can see like heaps and maps now. So when we are talking about this, we are talking about a way we are going to use the binary tree in certain way. Heaps are a really cool and efficient way to store information that will be used to always have the minimum element inside the tree at the root, or the other way, if we invert the condition of sorting, we can have the maximum element in this uh, in this structure, and that is really cool because sometimes you have problems that requires you that to always subtract the minimum element of a scope of information. So well, accessing the element, as you can see, will be always calling always calling just the root. So pop the root and give me the root, and I will always have the minimum element. The only drawback is that you have to maintain the order each time you insert or delete an element inside this structure. Doing this may or may not be really hard depending on the implementation you have. You can look in the internet how to implement a min or max heap, and that will be really fast. So yeah, each time you have a question or a problem that uses or relies on having always the minimum element or the max element at hand, you will need to think about heaps and maps, and that will be another way of solving it. Well, when we talk about maps, we are also talking about a way we can store information and accessing them by another way other than a number. When we are mapping information, we are saying that we have, for example, an array, but instead of accessing the element by an index, we can accessing them by a different name. For example, I could say like um, nutria. If I put nutria, I want to retrieve the number 10, and that would be a better and a better way to save information and always know how to access them back, other than remembering the a random number.
Can everyone hear me?
Yes, I can hear
Yeah.
you.
And can you confirm that everyone can see the presentation? Or anyone in the comments, please.
I can see the presentation, yes.
Okay, sounds great. Okay, so we're advancing to more advanced sections, which is now graphs. So notice that a difference between graphs and trees is a little bit small, right? It's just that a graph can have some cycles, and a graph is not necessarily something to say about graph is that it's not necessarily just one connected a graph, right? So it can be like also a tree. So yeah, what that's the first thing about graphs. In interviews, graphs are not a common topic. However, we have encountered in our experience that they have appeared before. So I'm going to talk a little bit about what kind of problems we can find that involve graphs. So first of all, let's distinguish between these types of graphs that you see in the image. So they are almost identical, except that one of them have directed edges, right? So this will be called a directed graph, and the other one will be called undirected graph or bidirectional graph. Because if you can see, if I put an edge in the opposite side of each edge, it would be like that it has both directions, right? So if I do this, then it will have both directions. So it will be either unidirectional or bidirectional graph. So the algorithms that we can run in other graphs in an interview most commonly are BFS, which is breadth first search, or DFS, which is depth first search, or well, there are other algorithms that are based on this. Also, some other more algorithms that are a little bit more complicated could involve a find the shortest path to get to some point, or find some node inside the graph. And then if that is the question, then you could ask if the node exists first in the graph, right? So this can be like some examples of questions that you can find in graphs. I will do one example just to show you what a BFS could look like here. So taking this graph, we can traverse in a BFS way. So BFS is just a traversing by levels. So for example, if I say that this is level 1, then all the nodes that are connected to that node, they will have level 2 right here. Level 2, level 2, level 2. And then the other nodes that are connected to these nodes, they will have level 3, right? So this one's level 3. And then the rest of the nodes will have the next level, right? So 4, 4. So this is just a technique that is quite used in graphs, and it can help you. For instance, in this case, we can find the shortest path to some node. Notice that there is no weight in the edges, so we can simply say that each edge can we can say that the cost of traversing through each edge is 1. So notice that using this technique, we can also find the shortest path to reach, for example, this node. So notice that we first reach this node using this path. Oh, I forgot this one. Okay, so let's say that this edge does not exist. So the shortest path would be going
I don't
from
see
this
your
node
pointer.
to this node. So notice that it's shorter than this one, right? So that's also how you could use BFS. And DFS is just traversing the tree in some kind of random way, but you will be looking for some objective. The simplest case that I can think of is if you want to find some node. So for example, let's say you want to find the node that contains the number 5 as value, then you would do a depth first search, and you go for all the nodes and you keep searching. Right. Let me see, I think there are some comments. Okay, yeah, we can continue. So like those are just some examples of how we can use graphs. So these examples also work in directed graphs, etc., etc. Also, a common problem would be topological sort, where those algorithms, we're going to talk about them in the next session, which will be strategies. So yeah, I think that's it for graphs. The next topic would be hash. And well, for hash, this is the most common use case, which is just a mapping some value to some other value. It can be string, it can be number. So basically what we do here is that we, for example, here, Sergio Sanchez is mapped to node 152, right? So by using some hashing function, what we're doing is that in between, we're applying some mathematical formulas there. And once we're done with the computing of this, we get some hash. This is what is called the hash. It can be either a number, either a string, some way to represent that Sergio Sanchez corresponds to this value, right? Now, once we have this value, then what we can do is say if you have this value, then you know that it means that it represents Sergio Sanchez, right? So here you can see that we can use this value to say, okay, so you're Sergio Sanchez. And one thing about hashing functions is that they can have collisions. So also we see that Hugo Duarte is mapped to the same value here. So this is because we are having a collision. So Hugo Duarte is also mapping itself to the same number, 152. So this is the big issue when we use hashing. So our function here should be like really robust to avoid these duplicates. Notice that the solution is simple. You just have to traverse through the list of duplicates until you find the one that you want, right? That will be the only thing. And some problems that you could use hashing would involve, of course, just mapping one value to another, but probably you want to have like an array or some set of items, and you want them to be unique, for example. So you can know that if an item exists in your array, you can use this hashing technique using a hash table, and you can query this hash table, and it will tell you whether the item that you want to insert into your array already exists or not. So that's a way that you can keep unique items. Also the other way around. So that's the most basic way to use hashing. In C++ or in most languages, this hash table already is included. I think in Python is called a dictionary. In C++, you can use unordered map or unordered set. Both of them use a similar technique, except that the unordered set is just, as its name says, is just a set that contains items, and those items are unique. And the map is just basically this thing that you're looking at in the screen. Okay, tries. Okay, so tries is a very, very uncommon topic in interviews. However, sometimes in Google interviews, it has appeared. So one thing to mention is that Google interviews are a little bit more focused in this type of problems that are a little bit harder, not necessarily harder, but involve like heavier data structures or a little bit more of knowledge. So one example of this is tries. Just to explain a little bit about tries, is that we have like a set of strings, and what we want to do is like store them somewhere, right? So one data structure that you could think of is like, okay, let's have an array of strings, and then a string 1, a string 2, blah blah blah, and then you store them, right? So let's analyze the complexity of this, the space complexity here. So we will have, let's say that the length of each string is n. So if we have, let's say, k string stored, then the complexity in terms of memory will be n times k, right? So this will be in terms of big O notation. N times k. This will be the amount of space you will require to store all of this. And then let's say that you want to find some string, or let's say that you want to know if you have some string inside this array, right? So the time complexity for that operation would be traversing through all the strings, right? Comparing your string with all the strings here. That will cost you, again, assuming n is the size of all the strings and k is the total of all the strings, and the time complexity of that operation will also be n times k, right? And until then, you will know that you have a certain string. Now, this is where try help us. Try is going to help us because it's like a dictionary that stores a lot of strings, but it does it in an efficient way. So for instance here, let's say we want to store the word dog and the word do. So what it does is that it stores them like in a kind of tree. So you can notice that here is the letter D, and then here is the letter O for do, So this is one word. And notice that we mark it in the tree as some, we'll leave some marker there to know that that is the end of some work. So we have the word do, but then we also wanted to insert the word dog, right? So to insert the word dog, all we needed to do was to add letter G to our current tree, and also add our mark here. Something like this. So notice how this is already more efficient, because instead of repeating do again and storing one string for do and one string for dog, we are just using the previous string already stored to create the new string that we want. And we'll repeat all this process for all the strings that we want to store in this try. So for instance, here we have a word is drag. So drag from here. Notice that the words that are not marked with this red dot, those are not words in the tree. But for instance, let's say if I want to insert DRA as a word, then the only thing that I need to do is to add another mark in this node right here. So after A, just mark it as if it's an end of the word, and then I don't need to insert any other word. Now let's analyze the time complexity for querying if it exists the current word in this tree. So all we have to do, let's say we want to find if in this tree we want to know if there is the word top, right? So all we have to do is check if there is a T in the tree here. So we'll check T. If there is a O after the T in this tree, so we will go here, right? And then if it is a P in the tree, and then we will go down here, and we will notice that it is marked. So the answer would be yes. So the total time complexity for this type of queries will be just the length of the string. So we will be O of n. And also this place complexity will be, of course, much less than n times k, right? So this is the advantages of trees. It's important for you to train this type of structures. It's not that complicated. Although there are not a lot of problems in interviews that touch this topic, I would recommend it to know. Sometimes the interviewer just asks you if there is like some other data structure, or if you can think of a way to optimize your current algorithm, and they don't ask you necessarily to code the whole thing. So if you know this structure, you can mention it, and that will be like a good extra point in your interview. So that will be for tries. So let's move up to greedy algorithms. So greedy algorithms, I think it's the most common one for interviews, or the most common in general, because greedy algorithms are those that you can think of a solution in a greedily way. This sounds like a little bit recursive, but let's try to understand with the image here. So notice that here, if we choose a greedy algorithm, we could say, for example, let's take the greatest number in each node, and that will give us the greatest sum, right? So our objective is to find the greatest sum, and our current algorithm will be, okay, just take the greatest item in each iteration or in each label, right? So going for the greedy one, we will take 7, and then we will compare 3 and 12. So 12 is going to give me a greater value, right? And then we're here, and then we compare 5 and 6, so which is 6, because it's giving us a greater value. So this will be a greedy way to solve this problem. However, it is not the correct one. You will see that if I was not following that greedy algorithm, I would end up with a greater sum because I could choose 99, right? So notice that greedy algorithms are sometimes hard to think, but some others are just as simple as just, okay, let's just sort some array, or let's just do some operations over some tree, which just makes sense, right? So this is like the type of approach you want to have. And also you want to consider always if a greedy algorithms really work. In your interview, what I would suggest is, before actually coding a greedy algorithm, I suggest you to be completely sure about that your algorithm works. So try to do is as many test cases and try to test it really well, so that you really know that this greedy algorithm will work. Because otherwise, it could happen that we find ourselves in this situation, right? That our greedy algorithm will not work, and we'll need some brute force approach, possibly just traverse through all the possible paths, and then that will give us the right answer, right? So just be careful when approaching some problem with a greedy technique. And so if you notice that your greedy algorithm will not work, the most common way to solve it then will be dynamic programming. So dynamic programming is basically attacking the problem using brute force, but reusing some of the soft problems that you have solved before. So let me see. So for example, this matrix here. So what we want is like the possible ways to reach this path, right? And then the sum of the edges here. So notice that there are a lot of paths to reach this corner. So the bottom right corner from the top left corner. There are a lot of paths, but if you are like in some path that is already near our goal, then you can already count how many paths were, right? So for example, if we are at this intersection, we already know that there is a path here, so one path, and then there are a second path here, so there are two paths if you go to this position. So if you ever reach this position from anywhere, so let it be from left, let it be from top, you already know that there are two more ways to reach your destination. So you don't need to compute that again. You can reuse that result and just add it to your global answer, or just your total result. So this is like the way we can think of a dynamic programming. It is also not as common, but it is quite popular in interviews. Also, this can apply in trees. This can also apply in graphs. This can also apply anywhere. So it's not necessarily a matrix. It could be just an array. One common problem that uses dynamic programming is check if an array contains two integers that add up to some number. That's a pretty common problem that uses dynamic programming. And also, you should be careful when computing the complexity of your dynamic programming algorithm. So usually, if you have to keep two states in your dynamic programming, then you will have to multiply the amount of states in the first, let's say, let me write this down because it's a little bit complicated. So, so let's say that for this one, I had to carry out with some states here. So it's gonna be I and J, right? So at each iteration, I need to know the position that I am right now. So I will have to multiply how many times I'm going to move I and how many times I'm going to move J. So that will be my time complexity. In this case, the most times I can move I is just going to 4 times, and then J is, I think, is also 4 times. So probably this is the complexity of just the states of your dynamic programming approach. Then you also have to compute what are you doing inside your function. So yeah, you just have to be careful. I really suggest you to study this topic. Yeah, I think that's it for our topics. Well, Andres already talked about the programming language knowledge and geometry. Geometry is just I think we have never seen this, but also if some interviewer noticed that you were like really good, probably your resume says something like you are a competitive programmer, or you are like really good with geometry problems, or you have done programs that involve 3D applications or 3D modeling, something like that. They could ask you to solve some geometry problems. However, most of them should be simple, like just compute probably how many triangles are in this 2D plane, or something like that. So basically just mathematics merged with a computer science here. And at this point, we're going to have a practice session, which Manuel is going to help us here. So
Well,
Manuel.
I only want to add in programming language knowledge also, well, as we mentioned, for example, if you put that you know a lot of C++, you could receive questions about the specific program, like, well, how manage the virtual memory, etc. Also, during your interviews, as Gobert mentioned in one of the previous lessons, you could receive questions like how the garbage collector works in Python and implement it, something like that. So that's referring to the programming language. And geometry as well as, well, probably as well as maths, but less general, could help you solving your problems. As Sergio mentioned, if you have a problem like 3D model or something like that, geometry could help you to solve any problem. Right now we are going to have, do you want to present, Sergio, or I return to my presentation?
I think it will be easier if we return to you.
Okay, let me change this. Okay, so now we will have quickly a problem. We don't have a lot of time, so here well, this is the, let me use the pointer. These are the steps that we teach you the previous lesson. So when you hear a problem, you need to listen, then you clarify, think, code. This practice is only for the first three steps. We don't gonna code anything right now. You can code it later if you want. But well, the problem basically says I'm going to give you an uncertain integer array. You need to find the smallest missing positive integer. What do you need now to do now? Well, I think here in the Discord we don't have a lot of people, but you can talk now if you want. You can send a message in YouTube, Facebook, also here at Discord. So this is a problem. Obviously, if you know the problem, please don't spoil the other persons. With this problem, what do you need to do? Hello? Any of the people here in Discord also can participate? Well, again, this is a problem, and the first step in the process is you need to listen the problem. Now you know the problem, so the first step is you need to clarify. Which clarifications do you think you can do?
En ese caso, ese missing, como falta de que,
Can you repeat, please?
sorry, yeah, like, what does it mean, like, missing? Like, what is expected in that array that something is missing?
Oh, okay, I understand. Sorry, I don't want to do that. Sergio, how can I make the notes here? Okay, well, missing is basically I will give you an array. Let's say I will put the example in the chat. I will give you, for example, 1 1 1 2. Remember, this is the input, and the output will be 3. Why? Because the first missing positive integer in the sequence is 3. If you check, you have 1, you have 2, but you don't have 3. This is what is referring to first missing positive integer. Well, or the smallest missing positive integer.
Okay, so it's okay to think the array is always gonna be like in a sequence, like 1, 2, 3, 4, 5, 6.
Do you mean like sorted?
Not sort, but like all the elements in the array.
Well, yeah, in fact, you need to find the sequence because I'm asking you to return the smallest missing positive integer. So in this case, yeah, a sequence could be 1, 2, 3, 4, 5, 6, 7, etc. And the first one, or the smallest one that is missing, is the one that you need to return. Is more clear now?
Probably like trying to write some example could help.
Okay, for example, if I give you let's say if I give you this example, which is the smallest missing positive integer?
6.
Yeah, that's right. So yeah, you need to find the sequence and you need to solve the problem. Do you understand better now?
I think also another clarification I will ask is, can we alter the input?
That's another good clarification. Yes, you can modify the input.
Okay, is it possible to have like negative numbers?
Yeah, it's possible.
Is there a possibility that you could like find like different missing elements? Let's say that I have like 1, 2, 3, I'm missing 4, but I have like 5, 6, and after that it's going to be 8. So I have like 2 elements. Is that possible a case? Well, is it possible?
Well, you can find that case, but in this case, I'm asking you to find the smallest missing positive integer. So the answer would be 4. Yes, as Orendon said in the chat, the answer is 4. Any other question? If you think that is enough the information, we can start with the next step, which is think.
Oh, okay. The example you say, Oredon, like 1, 3, 2. Yeah, it will be the next missing will be the 4.
Yes, that's correct. The answer is 4. So do you have any other clarification or do you want to start with the idea?
Is it possible to have like an empty array?
Let's say no, you will have at least one element.
So is 0 a positive integer for this kind of purposes?
No, and probably a mathematician will be having a heart attack right now.
Yeah. So for example, we have just negative, the next will be 1.
Yeah, that's correct. Any other clarification? YouTube and Facebook, you could also make clarifications in the chat. Okay, let me reopen this. Okay.
I have a
Okay.
question. So the integer representation is going to be like an integer or a string, because if we have an integer, we we are going just limited to the max integer, right? But we have a string, we can get even further. So the limits of that integer, how big it's going to be.
Okay, so the input will be an array of integers. Let me expand this to right here. Okay, so the input is an array of integers. The output need to be an integer, which is the minimum number. Well, the smallest positive integer in the array. Which other clarification happy ask? You could have negative numbers. Okay, I think I don't remember any other clarification that we have done.
I think that if we only have negative, then the 1 is going to be the
Okay.
like,
Let's say first possible answer is 1. Or minimum possible answer. Okay, any other clarification?
that the input is always will have at least one element.
Oh yeah, that's right. At least one element.
And we can modify the input.
Oh, come on. The input.
Can we use extra space?
You could, but if you could solve it without any extra space, will be better. Any other question? No? If not, we can start with the idea. With these clarifications, how you solve the problem?
I think it's important to like start with brute force way of solving it, like the first that comes into your mind.
Okay, and what is that solution?
For me, it might be just searching for a number each time you iterate the array. So it means that if the array is of size 5, maybe you can search for the number 1 to 5 each time you iterate through the array. So that you will iterate 5 times, and you'll search for 1, then for 2, then for 3, and so on, until you find the first missing positive number. That's it.
Okay, and what's the complexity of that solution?
That will be of O of n squared, because we will iterate through the array n times. So that will be iterating n spaces n times n squared. Yeah.
Okay, let's write again here. Okay, current solution is brute force. Oh well, we are running out of time.
Yeah, I think well, I have a really an idea that if we can modify the input, maybe we can convert this rate into a set, and after that we can also make a sort and just iterate to look for the positive.
And what's the complexity of that idea?
Yeah, making the set may just going to be well, if we first make the if we first make the sort, will be n log n, where we're just going to be like n the number of elements. We will be using, for example, quick sort. Then we can make a set, just eliminating the elements. Also will be linear, and then searching for the next positive integer will just be also linear.
So this is linear in time and in space.
In space, if we use the same array as the input, will be constant.
But do you mention a set, right?
Yeah, but you can. Well, I'm thinking in Python, and Python you can use the same array as the set output, just like I'm in place.
Okay, could you repeat me the idea?
Yeah, like in Python you can convert the same array into a set. Like but
Yeah, but if you convert it directly, you will lose the information, the input information.
yeah, but we can modify it, right?
It's okay, I'm not sure how Python works, but basically you will say input equals to set input.
yeah, something like that.
Okay. Do you know how
But
works the set internally?
yeah, like that in that way. I mean, like if you do it like way, yeah, we will like delete it and create a new element. But I was thinking more like in place set operation. Like that's what I was thinking about first, making the sort. And if we have the sort, we just like taking element by element. Like the sort will be the set manipulation will be in place. And also if we
Okay,
just
I'm not sure how works Python internally, but okay, in this case, if works as you said, will be constant in space.
yeah.
Okay, I will trust in you. We have a question. What's the answer for 1? In this case, if you have only 1, the first missing positive integer is 2. So that's another hint. What is the maximum possible answer? Hello?
Yeah, it's going to be the next element that's not inside the sorted list.
Yeah, but we mentioned that the minimum possible answer is 1. What's the maximum possible answer?
The size of the array plus 1.
Are you sure of that?
No, it's going to be
No, it's the max element plus one, because for example, what happens if we got like 2, 3, 4, 5, 6, 7, so on until like 10, and let's say that our array has negative numbers, right? So it's the maximum element
Are you
in the
sure
array
of
plus
that?
one.
Yeah, I am sure that is the size of the array, because if you like sort the elements and use the indexes, you're gonna have I don't know how to say it. Okay, imagine that you are like swapping the elements in the position that is the correct position. Okay, if you have the correct position of those elements, you're gonna have elements that are missing in the middle. Okay, so if you traverse from the beginning to the end, you're gonna have like a hole inside the array. But if you can like swap all the elements, and at the end you're gonna have the size of the array plus the next element. I don't know if it is clear.
But you mentioned that the maximum possible answer will be n plus 1. N is the size of the array. Is that right?
maybe not, because we can have an array of just ones, and well, we can have like 10 ones, and the next maximum will be just 2.
Okay, probably
No,
it could be a clarification if there are just unique numbers of can be repeated.
Yeah, can be repeated. But well, that's only a tricky question. Yeah, the answer is n plus 1. I only want you to suffer. Yeah, and the answer is here. You have 2, which is the size of the array, which is 1. n equals to 1, and the answer is 2, n plus 1. Orendon shares his solution. Yeah, that's a solution. In this case, he says that is n log n. That's right, because of the sorted part. So right now we have 3 solutions. And right now the best one is, well, if it's right, the thing that Andres said, using the set is, well, converting the array to a set is constant in space and linear in time.
Yeah, he's correct.
Okay, as Eric said, the solution is, well, if you don't have Python with magic things that works, you can use the array as a, well, as a way to store the indexes. Can you explain again, Eric?
Okay. You have like imagine that it's like a bucket. Okay. So if the elements are unique, in one pass you check. Okay, I am in the correct position. If yes, I move to the next one. Okay. And I check I am in the correct position. If no, I try to swap with the correct position. Okay. Imagine that you have like I don't know, 2 and 1. Okay. Just 2 and 1. So if you are in the first element, you can see that is the element with the value 2. So you need to swap it to the next element, okay? So you swap the element with the correct position. And now in the same position, you ask, I am in the correct position? If yes, I finish and I move to the next one, okay? And now in the next element, I ask again, I am in the correct position? And you can see that, yes, I am in the current position, so I move to the next one. But I finish traversing the array, so it's not necessary to do anything else. So the next step is, okay, I traverse again the array, but I'm gonna check if all the elements are in the correct positions. If one of those elements is in the wrong position, it is the missing one, okay? And that's the answer. But also you need to check if the element that you need to swap is not out of bounds, okay? Because imagine that you have, I don't know, 1 and 100, okay? You have just 2 elements, but one of those elements is very, very large, okay? So if when you are trying to swap those elements, it's impossible to do it because you don't have a valid position in the array. So you need to fix that like bug. Spanglish. Okay, it's fine.
Yes. Well, this is more or less the idea. So here you ask if it's in the correct position. If it's not in the correct position, do you swap it with the correct with the correct position? In this case, will be more or less like this. And you do the same. Is this in the correct position? Yes, it's the correct position. So you move to the next one. Is the 2 in the correct position? Yeah, it's in the correct position. So in the next iteration, you will be in the end, and you need to iterate to find the first missing. In this case, you will say, okay, 1 is missing, no, 2 is missing, no. So the correct solution will be 3. This is more or less the idea. Well, it's explained a little quickly because we are running out of time. Only I want to clarify. Yeah, I think I can write it here. Basically, you don't care of negative. Well, let's say of elements less than 0. Why? Because your first possible answer is 1. And also, you don't care of elements bigger than n. Why? Because your possible maximum possible answer is n plus 1. So, and this is only the case where all your elements are filling, which is this case. 1 and 2, you have all the elements filled. so you don't care about the 3, 4, so on. So with this in mind, the idea is basically this. You use the same array as a bucket and you change the elements to his correct position. You only need to take care of, well, in the case of the repeated numbers, and I think that's all. That solution is also linear in time and constant in space. But if you have Python, you can use the set, which is the same idea, but with magic behind.
Yeah, but
Yes.
I'm not sure if I mean the set is gonna create. I mean, it's gonna use extra memory anyway.
Yeah, I
But
agree with that.
well, as Andres and Gober said, I think reuse the same memory from the array, as far as I understand, at least.
Wait, but the Andres ideas was different, right? Is used to use like an array as a set. Am
Yes,
I
yes.
correctly? Yeah, exactly. That's
Yes.
why we said that it was of one in
That,
memory.
that's why I say it first has to be assorted, so we can use the same array.
Okay,
So the
but you
time
sort the idea.
complexity is not
You sort the answer, the array. Sorry.
Yes.
Oh, so it's en log n. Okay, never mind. Using the set is en log n, which is more or less the idea of Orendon here. Okay, so the good answer is this one. You use the same array as a bucket. And well, here is the problem. It's called first missing positive integer. You can solve it. In lead code, it says that it's hard. So don't worry about that. It's not really hard. Well, in my opinion, at least, when you get the idea.
Also, I came up with another. Well, it doesn't matter. Never mind.
Well, yeah, you can make modifications with other. I think there is. Well, you can look for more small problems here. So that's the problem. It's really nice. We won't code it, but well, the code is this. You can see it here. It's a spoiler. So with this, the more focus is the clarification that you need to do. If you notice these two things, I mean the solution is really cool because and also that you can use the input, well modify the input, so is solution in place. So that's everything for now. We're running out of time like 15 minutes ago. So thanks to everyone for take attention. The next Wednesday we will continue with the last topic. Well, yeah, the last topic of this workshop, with these strategies and patterns. And the next Friday will be the last formal lesson of this workshop. Will be a session with 2 full-time employees. You can prepare another questions. Probably will be in Spanish, I'm not really sure. One of them wants to speak in Spanish because works in Microsoft but doesn't want to speak in English. So it's your time to use that to ask your questions in Spanish. And well, thanks to attend this lesson. See you next Wednesday.